So in this video, we're going to be looking at solving quadratics using square roots. And a general idea of this is, let's start with these practice problems. If we have x squared and we're trying to get this x by itself, so that means we're trying to get rid of this square exponent or an exponent of 2. To do that, we generally use a square root. So we take the square root of it on both sides, and that helps us cancel out the square. So roots, square roots, and a exponent of 2 cancel each other out. So that means the x now drops down. The square root of 25 is, well, two numbers that multiply to give you 25 is 5 and 5. So in that case, this is going to be 5. But that's not actually the final answer. So 5 times 5 equals 25. But if you think about it, negative 5 times negative 5 also gives me positive 5. So turns out there are two solutions, x equals positive 5 and x equals negative 5, right? So this could work as a solution. Or another way we can write positive and negative is using this symbol, plus and minus, where you put the plus sign and the minus sign together and just write the number that you're saying that could be positive and negative. So these two are going to be our answers. So you can either write it like this as two separate numbers, or you can write it as joints using the plus and minus symbol. But either way, when you have a square, you use a square root to cancel out the square, and then just take the square root of the other side. So to cancel out a square exponent or a power of 2, use a square root. But let's try it with this one. This one gets a little bit tricky because I'm going to use a square root to cancel out with the square, right? That cancels. And then I have to take the square root of 8. Well, when we think about 8 doesn't have two numbers that perfectly multiply to give us 8. 8 will break down into 2 and 4. So I'm going to make a factor tree. And when I make a factor tree, I want to get down to the prime numbers. Prime numbers are essentially numbers that won't break down any further. So like 2 here doesn't break down. The only two numbers that multiply to give you 2 is 2 and 1. And so it's not necessarily to break down 2. So I'll pause on 2, go to 4. 4 breaks down into 2 2's. And when you're taking a square root, to simplify it, so I'm going to bring down my x that's on the other side. So I'm bringing down this x that the square and the root have canceled each other out. And when I look at this side here, I notice my prime numbers are 2, 2, 2, 3 2's. So what I'm going to do is basically find my pairs. So square roots are looking for pairs. Notice how the 5's here are a pair, and so that came out of the root. Well, there is a pair of 2 here that I can bring out. So that means this 2 can come out. And so I would have now a square root that will take in anything that's left over. So notice I have another 2 that's left over, but it doesn't have a pair to work with. So the 2 gets stuck into here. So put the 2 that is left over inside the root. So anything that's left over goes back inside the root. Now don't forget, we do need a plus and minus in front of our square root, because anytime you take a square root, there's always a positive number and there's always going to be a negative number. So I'm going to put the plus and minus there. And that there is our answer, because I can't break down the square root of 2 anymore. The only thing that comes out of a square root of 2 is 2 and 1 if I were to factor, which isn't a pair, so I can't bring that out. So just as a reminder, when you're decomposing or simplifying a root, what you have to do is decompose it using a factor tree. So find two factors that multiply to give you that number and keep factoring it until you get down to the prime numbers. So notice I didn't put the 4, I didn't use the 4 anymore because I've already factored down to its prime number. So I ignore the 4, I'm only looking at the prime numbers. All right, the next thing I want to look at is this one here, is 17. So I do have to take a square root on both sides. So the square and the 2 cancels. X comes down. But when I'm thinking about what two numbers multiply to give me 17, if I were to build a factor tree, the only numbers that work is 1 times 17. So because 17 doesn't break down into anything that we can pull out as a pair, like here we have a pair of prime numbers, we're going to have to keep it under root because it doesn't factor down to anything else. So this is going to be the square root of 17, but let's make sure we put a plus and minus sign in front. So every square root is going to need a positive and a negative sign. And that's it. So we got to see 3 different types. This one, square root, when we took a square root, it square root perfectly. So it's a perfect square root. This one is where you have to use a factor tree to try to bring out as many pairs as possible. And this one here is where you can't factor it down to any more because it's a prime number, so it doesn't factor out, so it goes back inside the root. All right, let's get started with example 4 here. So we're used to solving a quadratic by setting equal to 0 and trying to factor it, the trinomial or binomial, and then setting the factors equal to 0. But what if I told you that you could actually you don't need a factor all the time. You could use square roots to help you cancel out the power of 2. If you were to do that, you don't have to rely on factoring because not everything is factorable in the world. So that's a huge advantage. So what we're going to learn today is how to use square roots to solve for quadratics, to cancel out that power of 2. So when I look at this problem here, the goal is to try to get the x squared by itself, because if I can get the x squared by itself, then I can take a square root. So I couldn't take a square root right away because then I would have to try to work with taking the square root of negative 89. And that's a little bit hard because that negative sign's in the way. So what I need to do first is try to move the 289 to the other side. And I can do this by adding 289. So that cancels, and x squared comes down, and this is 289. Now, notice this problem is very similar to the warm-up now. So I have, the x squared on its own and a number to the other side. So I can try to get rid of the square by taking a square root. So you only want to take a square root when you have the x squared by itself. So the x squared cancels, x comes down. The square root of 287 is actually a nice number. I think 2 numbers that multiply to give you 289 is 17. 17 times 17 gives you 289. Let me move this down just a little bit. So 17 is my answer, but don't forget the plus and minus in front. And there we go. So their solution is going to be positive 17 and negative 17. So if I were to draw this quadratic equation on a graph, that means that the parabola would hit it at positive 17 and negative 17, which is kind of hard to see when you're making a graph. But in this case, we found it algebraically, so it was so much easier to solve it algebraically than making a graph. All right, on this one here, to try to get this x squared by itself, I think the furthest thing away is this negative 10, right? Just using that principle, if you want to get a variable by itself, move the thing that's furthest away. So the negative 10 would be moved off first. So I'm going to add 10 to both sides. 2x squared comes down, and this is now a positive 10. I'm going to divide by 2 to get rid of the 2 that's next to the x. So x squared comes down. And this 10 divided by 2 is 5. Well, to get rid of the square, we have learned to take a square root. So the x comes down. Now 5 doesn't decompose into anything because 5 is a prime number. 5 can only decompose as 5 times 1. So that is not going to be helpful for us. So we're going to keep it under a root because it's a prime number. It doesn't decompose. So I'll bring down the square root of 5, but I need to put that plus and minus in front. And there we go. All right, moving on to some fraction problems here. So this one has a 1/3 next to it. So we'll practice, remind ourselves how to use fractions. But first, let's try to get the x squared by itself. So I need to move over the 4 by subtracting 4 over. 1/3 comes down along with the x squared. And 8 minus 4 is 4. So now we can see there's a 1/3 next to the x squared. So we're trying to get this x squared by itself. I want you to notice that this 1/3 is sitting next to the x squared, so it's multiplying. To get rid of multiplication, we have to divide it off. And so when we divide it off, we need to divide it to the other side. So this side will cancel because they're the same, top and bottom, so they'll cancel. We'll bring down the x squared. And to divide a fraction, we always flip the denominator, so or the thing that you're dividing with. So I'll bring down the 4, and I'm going to flip the 1 over 3 to 3 over 1. And when you divide, you have to multiply by the reciprocal. So this 4 comes down, and I flip this guy, so I'm multiplying by the reciprocal. Now from here, I'll have the x squared. And if I want to multiply the 4 with the fraction, I could put this 4 over 1. 4 times 3 is 12. And then the 1 times 1 is just 1. So that's just going to be x squared equals 12. 12 over 1 is just 12. Now from here, I can see that this is a square. So I'm going to take a square root. That cancels. If I were to decompose 12, that could be 4 times 3. 4 can decompose as 2 times 2. So I do get a pair out. Looks like I get a 2 to come out. So I'm bringing down my x. So I brought out a 2 because there's a pair of 2's. And the only thing that I have left over is this 3. So the 3 goes back inside the square root. All the leftovers go back in the root. The 4 has already been decomposed into 2, so I ignore the 4. And I need to put a plus and minus sign in front of our number. All right, and there we go. We have our solution. So the tricky part with this one here, I think, would have been this 1/3 that's in front of x. So whenever you're given a fraction, you can divide it off. If it's sitting next to it, it's implying multiplication, so you can use division to kind of cancel it off, and so you have to divide the other side. But I also want to teach you, a lot of people will see this problem and they'll notice it's a fraction, so they multiply by the reciprocal. So some people will just multiply it by 3 over 1 in the beginning and multiply 3 over 1 to the other side. It just skips a few steps here when you do that, which is perfectly fine. All right, for D here, I'm trying to get this x squared by itself, but there's a lot of things moving around. So I notice there's a 3 in front of a parentheses. There's no exponent on this parentheses here. So I can distribute this 3 inside, which would give me 3x squared minus 12, 2x squared minus 1 on the other side. So what I notice next is that I have x squares on both sides. It would be great if I could just have one side to be x squared and one side to be numbers. So that's what I'm going to do. I'm going to move the 2x squared to the other side. It doesn't matter which side you move it to, but I'm going to try to move it to one side. And so 3 minus 2 gives me 1x squared, or just an x squared. Bring down the 12 and bring down the negative 1. And now I can move the 12 over to the other side, so I can try to make this where x squared is by itself. So the goal generally is to try to get the x squared by itself. So negative 1 plus 12 is going to give me 11. If I were to take the square root on both sides, the 2 and the root cancel, x comes down. Square root of 11, 11 is a prime number, right? 11 times 1 gives me 11, but nothing else. So we do have a prime number, so we have to keep it under a root and put the plus and minus sign in front. Don't forget that piece. All right, so we've done quite a few practice problems with this. I also want you to notice that because we have a plus and minus in front of all of these problems, we have 2 x values. We have a positive version and a negative version. So I want you to notice that the quadratics that we're solving for still have 2 solutions. In this case, a positive version and a negative version. All right, let's try out our last set of problems here that I want us to analyze. So it says here, can you distribute a constant in a parenthesis that has an exponent of 2 or a higher power? Explain your reasoning. So what it's asking you to analyze is when you look at these 2 problems here, notice how there is a number in front of the parentheses. And the problem that we had before also had a number in front of the parentheses, and we went ahead and distribute that. But there was a reason why we could do that, and it has to do that there wasn't any exponent here that basically limit us from distributing. So notice how this one doesn't have an exponent, but this one does. The x squared is now on the outside, right? The square is on the outside. So that means I can't distribute it in. And the reason why is because of order of operation. If we look at order of operation, it's please excuse my dear Aunt Sally or PEMDAS. It always says that parentheses comes first. So inside the parentheses, I can't, combine x and 1 or x plus 4. Exponents come next. And if exponents come next, that means I have to take the exponent first before I can multiply. So the 2 and the 3 that's in front is sitting next to the exponent, so it's implying multiplication. So that's why I can't distribute or multiply in first before I take an exponent. So when I'm looking at this problem, I can't distribute. So no, I can't distribute because order of operation gives the exponent a higher power. So states that exponents are handled before multiplication or distribution. I think that's how you spell that. Forgive me for my spelling. So from here, what we would have to do instead is if there's an exponent here, right? X is inside, so we're going to move the thing that's further away. In this case, x is inside of a parentheses that's being squared, so the 2 is actually the furthest thing, or the number in front of the parentheses. So that's going to need to be divided off. So I'm going to divide it to the other side. I would have x minus 1 to the second power that's left over, and 8 divided by 2 is 4. Now that the number in front is gone, I can take care of this square. So to get rid of a square or power of 2, I have to take a square root. Notice that I am square rooting everything because everything here is being squared. All of this is being to the second power, so I have to take the square root of all of it to get rid of the square. So I have to take the square root of the other side. X minus 1 finally drops down because the 2 and the root cancel. Square root of 4 is 2, but don't forget the plus and minus 2 because I think that will be the first thing people will forget. Now, once you have this part, you have a positive and a negative 2 to work with. So I would recommend split this equation up into two equations. X minus 1 equals positive 2 and x minus 1 equals negative 2. And then continue to try to get x by itself. So I split them up into two equations. I'm going to add over 1 to both sides. So my x equals 2 plus 1 is 3. And negative 2 plus 1 is negative 1. And there is my two solutions. So x equals positive 3 and negative 1. All right, so for this next one here, again, you have something that is raised to the second power. So because there's an exponent here that's higher, 2 or higher, you can't distribute the 3 inside. So instead, we have to divide it off to get rid of it. So I'll divide off the 3. That leaves me with x plus 4 squared on this side. 9 divided by 3 is 3. And now I'm going to try to get rid of this square because it's encapsulating the parentheses. So I'm going to try to use a square root to cancel it out so I can get inside the parentheses. So the x plus 4 comes down. Square root of 3. 3 is a prime number, so we have to keep it under a root. And I'll put the plus and minus in front, so don't forget the plus and minus. And then I'll go ahead and split this into two equations. So I have a positive square root of 3, and I have a negative square root of 3. I want you to notice that I'm not changing any signs on this side. I'm just using the positive and the negative version on my right side that I've taken a root of. So I'm not changing the signs of the 4. So from here, I want to move the 4 over by subtracting. So this cancels. I have x equals root 3 minus 4. Now this 4 is not under a root, so I'm just going to carry it down with the root of 3. So when you have a number that's not under a root with a number that is under a root, just treat them like they're not like terms. So you're just going to have them together, but you're not going to combine them. This one I'm also going to subtract the 4 off. So x equals negative root 3 minus 4. And those are my two answers. So x could equal positive 3 minus 4 or negative root 3 minus 4. And there we go. All right, so down below there's a bunch of practice problems to try out to practice your skill. I hope you found this video helpful. If you have any questions, feel free to email. All right, bye guys.